Welcome to GATE 2021 model questions on control systems. Today's our topic is time response analysis. Let us see the question number 3. For the system shown below, determine percentage peak overshoot and rise time. So this is the block diagram they are given and options for us. Let us go to the solution. So this is a block diagram given and asking your time response specifications. But first you have to find the transfer function of the given block diagram. What is C of S by R of S? We'll apply Maze's gain formula in finding the transfer function. Okay. For how many forward paths we'll have from R to C is one forward path gain is straight away like this. For one forward path gain, we have it from R to C is like this. 10 into 1 by S plus 12 into 20 by S, which will be writing as 200 by S into S plus 12. This is one forward path gain P1. Next, second forward path gain. What we are having is here, another forward path gain is from input to output you can reach in this manner also. You can go like this, you can come down and go like this and reach it back, same output C. Here also the forward path gain is 10 into 1 by S plus 12 into 20 by S. For hence the forward path gain here also it is 200 by S into S plus 12. So these are the two forward path gains we have it here. Now what is delta is 1 minus of sum of loop gains. How many loop gains we have in this block diagram is totally 3, in which one loop gain we are showing as this one. So one loop gain is like this. This one. Start at this node and go 1 by S plus 12, then 20 by S and point to S. So this is one loop gain which is a negative feedback or negative loop gain only. For hence that loop gain will be, when you simplify it, is 1 by S plus 12 in 20 by S into point to S. So 20 to point will give 4 by S plus 12, which is a negative sign. Another loop gain what we'll be having is this one. Starting here only, again going like this and reaching back like this. It's also negative feedback path. So what is this loop gain is 10 into 1 by S plus 12 into 20 by S, only with a negative sign. Therefore minus 200 by S into S plus 12. Another loop gain is 1 minute. Yes. Another loop gain what we have it is, we can come downward also and we can reach same manner like this. That is also same loop gain, that is minus 200 by S into S plus 12. All the loop gains are touched. In forming these two forward path gains also the three loop gains are touched, hence delta 1 delta 2 will be equal to 1 only. Hence your simplified closed loop transfer function will be 400 by S square plus 16S plus 400. So this is a transfer function which is nothing but your standard second order system transfer function only, whose characteristic equation is S square plus 16S plus 400 equal to 0. When you compare this one with the standard second order system characteristic equation, S square plus 2 zeta omega ns plus omega n square equal to 0, what is the undamped natural frequency will be getting as root 400, which is nothing but 20 radians per second. And what is the damping ratio? We'll be writing as 16 by 2 into 20, which will be 0.4. Once if you know damping ratio and undamped natural frequency, you can find any specification. For whatever the first specification they are asking for us is percentage peak overshoot. What is the mathematical formula of peak overshoot is e power minus zeta pi by root of 1 minus zeta square into 100. Substitute zeta equal to 0.4 and solve it, we'll get 25.4 percentage. That is the percentage peak overshoot. Then what is the mathematical formula for the rise time is pi minus theta by omega d. What is here? Theta is cos inverse of zeta. What is omega n? Omega d is omega n into root of 1 minus zeta square. Substitute the data, you'll get the answer. What is the damping ratio? We got it is 0.4. Compulsory this cos inverse of 0.4 should be expressed in radians since pi is also radians. And what is undamped natural frequency is 20. And zeta is 0.4 here. Substitute it and calculate it. The rise time will be getting as 1.463 seconds. Hence, your correct option is answer is D only. Thank you. Any doubts, please don't forget to post in the comments box.